Hello team emertxe. So myself Devansh Jaiswal along with team members Sohanlal, Piyush and Elvin Paul. So today we will be explaining the microwave oven simulation that we did during our internship. So these are the table of contents which we will be discussing about. So first of all is what is microwave oven, the requirement it took, embedded systems, microcontroller, microprocessor, picsimlab, CLCD, matrix keypad, timer and project implementation. So the question is, what is microwave oven? So it is basically an instrument used to heat food using microwaves, which is in the form of electromagnetic waves. So there are several modes we will be using in this. First one is micro mode, grill mode, and the third one is convection mode, the fourth one is start mode. So in the microwave mode, which is used to cook the food in a traditional way, it uses a maximum power of around 900 volts and the food takes time of around 60 minutes. Second mode is grill mode. This is used to cook meat and bread. It uses micro mode, but the purpose is to cook meat. User can set the time as per the cooking time. The third is convection mode. In this mode, the user can set the oven to preheat for a particular temperature. It takes around 3 minutes preheat the oven, and after preheating it is done, then the user can set the time as per the requirements. So these are the following requirements it took. First of all, it took a knowledge in embedded C, then MPLab IDE, then the XC8 compiler, picsimlab, microcontroller PIC, and 16:4 CLCD, tactile switch, matrix keypad, and timer 2. So the next slide will be explained by our friend Piyush.
So hello everyone, myself Piyush Kumar. I am handled the topic of embedded system. So basic question arises, what is an embedded system is. So embedded system is a combination of any hardware and software which is used to do a specific task. So the question arises, what is the general purpose system and what is the difference between the general purpose system and the embedded system. So general purpose system is used to perform a large number of tasks, while the embedded system is used to perform a specific task. So we have different types of embedded system: standalone system, real-time system, network system and mobile. So we have to choose an embedded system to do any specific application. So there are so many criteria for choosing the embedded system. First one is low power consumption, second one is cost efficiency, third one is efficient use of processor power, reliability efficiently. So the basic of what is a microcontroller and a microprocessor. So microcontroller is nothing but it is an integrated circuit which is capable of doing a specific task. So we have in a microcontroller all the memory, input output capabilities, peripheral function is on a single chip. So microcontroller is, we can use a microcontroller for different applications. So we can choose a microcontroller based on their applications, performance, price, availability of tools and special capabilities. So we have know about something about microcontroller and microprocessor. So what is the difference between the microcontroller and microprocessor? Where we use a microcontroller or where we use a microprocessor? So the microcontroller, here all the components are embedded in a single chip. So all the components we have in a single chip, but in a microprocessor all the components are separately arranged. So the microcontroller are less flexible than the microprocessor, and also it is less design complexity than the microprocessor. So next slide is taken here by the Elvin Paul. So
myself Elvin Paul KS. I am going to talk about the picsimlab architecture. The picsimlab architecture consists of GPIO, general purpose integrated output, which is nothing but used for both input and output communication. It also consists of I2C, RTC, also EEPROM, LM35 temperature sensor, which is used to denote the temperature which is available during the operation of the picsimlab microcontroller. It also consists of analog to digital converter, RS232, which is used for serial communication with other devices, consists of LEDs, buzzers, digital keypad, SSDs, matrix keypad, and also in the end a CLCD. Now we are going to talk about CLCD, which is nothing but character liquid crystal display. In picsimlab there are two types of display. One is of 16:2 display and 16:4 display, which is basically the number of rows and columns in a CLCD. Now it displays the ASCII character and special characters which are used in our code. It is also mostly commonly used for displaying characteristics of the input and output which is present in the microwave oven. Now there are two types of communication modes, one is a 4-bit mode and another one is a 8-bit mode. Now I'm going to talk about tactile switch, which is nothing but a similar kind of switch having two inputs and two outputs, from which where VCC is given, from other where Vout is taken out, and one of the chip is given to the ground and another one is given to the VCC. There are two types which are used for pull up and pull in for both countersinking and current sourcing circuits, which is shown in the tactile switch. Now I'm going to display about the tactile switch's main characteristics, which is known as operation is perceptible by touch, which is nothing but if you touch the keypad it works on, and when you touch it offs the whole keypad. This switch is used to select the mode of operation and to enter the temperature and to enter the time in our project. This switch will produce a bouncing effect when a switch is pressed. And the coming slide will be presented by Sohanlal, and thank you.
Friends, this is Sohanlal, and I will be gonna explain you about the matrix keypad. So matrix keypad is basically a key presser in which we enter the number of keys, set the time as well as set the temperature. So this is a keypad in which the number of tactile switches are connected in a row and column concept. So this is also used when more number of user inputs are required and still want to save some controller input output lines. These keypads are most commonly used in telephones, calculators, digital lockers, etc. Now we are gonna talk about the timers, and the timers is basically a very important application in any embedded system, which is a default peripheral which maintains the timing of an operation in sync with a system clock or an external clock. So timer is basically a one which counts, and it has many applications such as measuring time, generating delays, etc. Now, timer or a counter is a software designed to count the timer intervals between the events. Resolution, which is also known as the register width, which is of 8 or 16 bit. Timer interrupt is referred as change from one number to another number. It may be up count or a down count timer. Now we will gonna talk about quantum. Quantum, which depends on the system clock setting, is a measure of time which is responsible for ticking of the timer. Ceiling may be a prescaler, or scaling may be a prescaler or a post-scaler. It may be 1:1, 1:8, 1:16, and etc. So we have modes of timers are counters and pulse width modulation and pulse generator, etc. Now I will be talking about the project demo in the next slide. I will be going to show you the simulation of our working model. So we have the power on screen, which is printed. Then we have 4 modes of operation, which is by pressing any one of the key mentioned, we can go into the operation of different modes, which is a micro mode, grill mode, convection mode, and start mode. So I will be showing you first the micro mode. So by pressing the matrix keypad switch 1. So the matrix keypad switch 1, when it is pressed, it shows a power equal to 900 watts, and you have the set time screen coming over, popping up, which is has the number of minutes as well as the number of seconds. You can press the number of seconds and number of minutes as possible, and you can use the star button to clear it off as well, and you can enter the number of seconds. And if you press the hash, so you have the start screen, which is the loading, the counter is decrementing from 25 seconds to 20 seconds, and we have these options. So we have the pause option, which is pressed by 5 switch, and we have also the stop. We have the resume option, which is pressed by key 4, and we have the stop option as well by pressing the key switch 6. So now we have the grill mode of operation by pressing the switch 2. We have set time screen. We can set the time according to our conditions and press the enter, and this is the grill mode working. in which the food is cooking, and we have the time up screen when the counter is completed loaded. Now we have came back to our original screen, and this is the third mode of operation, convection mode of operation, in which we are gonna set the temperature of any value. So I'm gonna set 56, and I'm putting a hash, and it has a preheating screen which is preheating time of 180 seconds. So our preheating time is over, and now we have the set time screen over here. We can enter the number of seconds, how many seconds we have to put for the timings of the microwave oven to function, and I am pressing 25, and this is the number of seconds, and I am entering number 1 minute and 25 seconds for the microwave oven, and I'm pressing the start button. And we have the three options displaying. One is the start button, one is the pause button, and another one is the stop button. By pressing any switch, you can also see the operations. We can pause it by pressing the key 5, and we can resume it by pressing the key 4. And if we press the key 4 like that only, so we have an increment of 30 seconds every time. And if we press the key switch, we have the stop option as well. So So the cooking is done and it shows the time up screen, and then it will come back to the normal mode of operation. And we have the fourth mode of operation, which is the start mode. By pressing the key 4, we are starting it, and it has a timer set which is of 30 seconds, and we are waiting for the time to get over. So the preheating time is now completed and the time up screen is paused, and this is the function of our microwave oven. Hope you like the presentation. Thank you.